Hello, my name is Ellen Spindler from Agilent Technologies, and today I will show you what's new on the J-BERT N4903B. First, I would like to explain the target applications for J-BERT. Then, I want to show you the new test requirements with the latest forwarded clock devices from PCI Express Generation 2 and Superspeed USB. And finally, I would like to give you a short demonstration of the new capabilities, especially in the pattern generator and in the user interface. So here is a view of the high-speed markets and technologies that can be addressed by J-BERT. The latest versions of the standards now approach the 5 gigabit data rate range. So here, quick path interconnect, PCI Express Generation 2, USB Superspeed or serial ATA, they are all running around 5 or more gigabit. And J-BERT High Performance Serial BERT offers the complete jitter tolerance testing for addressing both embedded clock devices and forwarded clock devices. So now I want to show you how to test forwarded clock devices with the J-BERT. Here is an example of a forward clocking architecture. In this case, this is an example of quick path interconnect that can be tested with the J-BERT. As you see here, forward clock devices requires that not just the data signal is transmitted, but also the clock signal. Usually, this is running at half the data rate. These kind of devices require very special testing capabilities. So the generator not just has to provide stress data signals, but also stress on the clock signals. And the new J-BERT has all these new capabilities that support testing of such forwarded clock devices. And now I will show you the new capabilities of J-BERT N4903B and how it addresses these new requirements. The J-BERT allows to generate half-rate clocks, and you can vary the duty cycle on that half-rate clock. This allows you to generate stress conditions and to emulate closed eyes. You can add jitter not just on the data signal, but also on the clock signal. And you can even delay the jitter phase on the data signal versus the clock signal. So all these capabilities help you to emulate stress conditions for your receiver using the forwarded clock architecture. Now I will show you another very popular application for the J-BERT, PCI Express Generation 2 receiver testing. As you can see here, PCI Express Generation 2 requires a very special profile of random jitter, which is composition from a low frequency and a high frequency RJ. And J-BERT now has all these capabilities built in and calibrated. But not just the random jitter, but also all the other jitter requirements like periodic jitter, SSC or residual SSC or ISI traces can be emulated with the J-BERT. And additionally, it also has now the ability to emulate electrical idle states, which are very popular on the serial bus standards, such as PCI Express. Another emerging application for J-BERT is USB Superspeed receiver testing. As you can see, there is a pattern generator needed, which allows to generate patterns and stress conditions, and you need to emulate a reference test channel. And J-BERT allows you, when used with an external clock source, to emulate all the stress conditions and patterns that are required to test USB 3 receivers. And here is an overview of J-BERT's major new capabilities. For the new forwarded clock devices, J-BERT offers the most accurate characterization because it helps you to emulate half-rate clocks and to add stress condition to the clock and data signals of these forwarded clock devices. For PCI Express Generation 2, it's the most integrated and simple measurement setup for compliance testing of receivers. You can generate all the compliance stress conditions with the J-BERT, and due to its built-in compliance patterns, electrical idle state, and variable output levels on all supplementary outputs, also the setup time for the compliance test is reduced significantly. For the other serial bus standards, there are a lot of other improvements in the J-BERT N4903B. The periodic jitter range is increased. You have variable output levels also on the trigger and auxiliary data output. The output signal performance is further improved, and our pattern sequencer has more blocks now, so this allows you to set up longer past sequences without interrupting any clock signals. And there is an upgrade path for customers who already own an N4903A to easily transition to the B. And now I would like to show you how we have implemented all these capabilities on the new J-BERT. Here is the pattern generator with a new auxiliary data output. This allows you to generate reference clock running at lower data rates. And both the trigger output and the auxiliary data output have now variable output voltages and offsets. On the user interface, let's start with the jitter setup menu. This is the new jitter setup screen of J-BERT. You can turn on and off the jitter sources here. And you can choose between the different types of jitter. Here, for example, you can turn on or off the second periodic jitter tone. If you want to vary the jitter amplitude and the jitter modulation frequency, you can do this by simply changing the value here. You can also vary the jitter modulation frequency, and you can choose the modulation waveform, sinusoidal, square wave, or triangular modulation. If you have to test a PCI Express Generation 2 device, you will need the spectrally distributed RJ. Here you can enter the different magnitude of the low frequency modulated and the high frequency modulated jitter. Here, this is residual SSC, which is commonly used in PCI Express Generation 2, especially for add-in card test. Here you can also set the modulation frequency and the 75 picosecond modulation amplitude. If you don't need residual SSC, you can use this instead for spread spectrum clocking or for sinusoidal jitter. If you don't need spectrally distributed RJ, you can also set up a normal random wideband RJ and bounded uncorrelated jitter. Here in this area, you can choose if you want to have the jitter just on the data signal or also on the trigger and the clock output. So now I have turned on the residual SSC also on the trigger output and the clock output. This delay here describes the phase delay between the jitter on the data signal and the jitter on the clock signal. So if you want to have periodic jitter on both data and clock signals, you can here easily change the phase modulation, the phase of the jitter between the data and the clock signal. So this is the new pattern generator output of the J-BERT. Here you see how you can set up the voltage levels and the offset for the data generator output and the auxiliary data output. They can be set up individually. So if you change here, you also have a graphical display of where in the voltage window your output voltage lies. You can change the delay between the data and the clock signals. Here you can turn on the new electrical idle mode on the generator output. And if you go to the clock and trigger output, here you can turn on the new half-rate clock mode for testing forwarded clock devices. You can easily change the duty cycle to emulate stress conditions of a non-ideal clock signal. And now I would like to summarize the key benefits of the J-BERT N4903B. It's the only complete jitter tolerance test solution which enables the next generation of embedded and forwarded clock devices. This tool allows R&D engineers to test high-speed serial computer, video, and communication devices up to 12.5 gigabit. This J-BERT has built-in, compliant, and calibrated jitter injection capabilities. It allows automated jitter tolerance testing. It supports testing of forwarded and embedded clock devices, and it can be used throughout the characterization phase and the compliance testing of new devices. So this was the summary about what's new on J-BERT N4903B. Thank you for watching.